Hey there, YouTube. I thought tonight I would demonstrate another routing protocol for you. As you recall, the last video I did was on EIGRP. Today I thought we would do another one. This one I decided to do, this is more of a basic routing protocol. This is RIP. This is one of the, if you're taking the CCNA classes, this will probably be one of the first routing protocols that you will learn about, just because this is very simple to set up. In that sense, it's kind of a dumb routing protocol, and what I mean by that is it doesn't really know what is exactly going on around it, as far as knowing when routes go down. From far away. The only way it finds out is from its neighbors after a long period of time, when a routing table will finally update itself and start to clear itself out. So with that, the RIP routing protocol it's very slow as far as a convergence, meaning that all of the routers or networks learn of other networks in the area. So as you can see on the program here, this is a Cisco Packet Tracer. You may recall some of the other videos I've used this program to demonstrate how some of the networks will function. This is a free program if you are a Cisco NetAcad student. Similar people who have been in the network engineering industry for a little while may have seen this program, may even have it. So if you're a NetAcad student, you can get this for free through cisco.netacad.com, .net, and download this. So with the RIP routing protocol, there's some stipulations to it. As I said, it's very slow convergence, and also you have a limit as to how far away you can talk to another network. So as you go between each router, that is a hop, and there is you have a maximum of how many hops you can go to, and it basically dies at 16 hops. So if there's 17 routers or 18 routers or whatever, you will not be able to get to those routers because it'll just time out. So that's one of the big stipulations, restrictions to RIP. And there was another restriction to it with RIP version 1, is it did not support variable length subnet mask, or VLSM. Basically, that means so you have a say a 192.168.0.0 slash say 32 network, which is actually what I have between each one of these routers. With RIP version 1, it does not see the non-classful networks. It will take that 192.168.0.0 slash 32 or 27, 28, whatever you happen to have, and it will make it classful, which means that the 192.168.0.0 is a Class C network, so it will force it in its routing table to be a 192.168.0.0 slash 24. So if you are trying to implement VLSM throughout your network, it just won't work. It won't know really where to go because it's trying to summarize all of these networks together. But that was fixed with RIP version 2, so you can actually do VLSM in that, which is what we will have to do with the demonstration that we have here, because I actually have quite a few networks. 1, 2, 3, 4, I don't know, 17 networks looks like. And I did that deliberately, that way I can demonstrate the timeout with RIP. So the timeout will occur when you're trying to get from router 0, which is up here, down to router 18, which you can see is the 192.168.17.0 network slash 30. So what we're going to do is, I don't have anything configured on here other than networks between all of these. So what we need to do is we need to go into each router and we're going to have to configure rep on each router. And this is very, very easy. All you have to do, router rep. Rep version 1 is now enabled. However, like I said, we are going to do version 2. Next, see, once I did router rep, it went to a config router. So you can do question mark and see what we have as far as our extra statements we can do. And you can see toward the bottom is version. We want to make this version 2 so we can do VLSM. And now you have a couple other things in here. You can do auto summary and set your administrative distances. So if you want to change it from the default administrative distance for RIP is 120, you can start changing that stuff down so you can make some of these routes take precedence over, say if you have EIGRP or something in there. You can change administrative distance on RIP to make it lower than, say, EIGRP or OSPF or whichever, for whatever reason, to make some of those routes go through and take precedence over EIGRP. So the other command we need to do on here is, even though we enabled version 2, by default it is still running classful. So we need to do no auto summary. So now that that's done, we can do our VLSM on all these networks here. So we need to put in our networks, so router RIP knows what networks need to be shared on its routing protocol. So this first network, we had a 192.168.0.0 network between here. So we will put that in. 192.168.0.0, and you see here that's it. It does not ask for a subnet information, unlike EIGRP. So that is in there. And then what you can do to see if it built into its routing table is you can do a show. I'll have to do it from here, so I have to do show IP route. And right now it's directly connected. It's 18.2. You see, I actually made a boo-boo here. This is this should be actually a 0.1. Like when I was going through doing all my stuff, I did not change my little script here. No big deal. We'll do a quick change here. Just hang tight while I make a change here. Alright. That looks better. Alright. So now we did our command in here to put the 0.0 network in router RIP. Now we'll go to router 1. And we're going to have to do this through all 18 routers? 18 routers. Yep. Version 2, no auto summary. Now we need to put in our network commands. We have a 0.0 connected to that one. That's between these two routers. The next network is actually a 1.0/30. So we will have to put that in as well. That one is in there. Shows it directly connected routes. Now, however, the 1.0 network is not directly connected to this router 0. So what we can do to see if it's working is jump into this one. And you can see this was just showing the directly connected network. As you can see by C, you can look at your little cheat sheet up here. C is connected. Now what we're going to do is show IP route again. And now another route just showed up. And that is R, which R is for RIP. And if you find up here, RIP. So that is there. And it's saying how it got its information. So it's saying it got the information of 192.168.1.0 via 192.168.0.2, which is the directly connected neighbor right here. 192.168.0.2, which is FA00 on router 1. So far so good. We are working. Now we're going to have to go through and do that on each one. If I can type. And we have 1.0. 2.0. I can go back in here and look at it again. We do not have a 2.0 yet. Let's go to 0.0. 2.0 should show up on this now. There we go. It took a second. Like I said, with RIP, it is pretty slow to converge, and that was just 2 hops away, and it took that long for it to finally show up. So that's showing up. So we will go on to the next router, and I am actually not going to keep this video going while I jump through all 18 routers. So I'm actually going to pause this video, and once I have the all the routers configured with the RIP command on here, you saw what I was doing. I was just doing router RIP version 2, no auto summary, and then put the networks of directly connected of that router to it. So hang tight, and I will be right back, and we will come back shortly. Alright, we are back, and I have all of my RIP commands configured on all 18 routers, and so let's take a look, see what we have. I'll start out with this one. Do a show IP route, and the last network that we have in our long line of routers is a 192.168.17.0/30 subnets between router 17 and router 18. So as I was saying, there was a limit as to how far away a router can reach, which was basically 15 hops. After 16 it dies. So let's take a look through here and see what we got. And you can see this goes in order. So we have 192.168.0.0, 1, 2, 3, 4, 5, 6, all the way down. And it stops at 192.168.15.0, which is, looks like the network between router 15 and router 16. So that is where it stops. So if you count the hops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then after this last network here would be 16 hops. So these are going to die off. Now if you kind of get in the middle here, say let's go with router 12. Looks like I already ran the show IP route command on this one, and you can see all the route commands on here. And this actually shows everything. Here's 192.168.0.0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's all the way down to 17.0, which is our last one. The reason for that is because of router 12 being in the middle, it can go 16 hops either way. And clearly, these are a lot less than 16 hops. So it's able to get all the routing information and store all that. As compared to router 0, it can't talk to router 18 because it's more than the maximum hops. So as much as we try, router 0 will never be able to talk to router 18 with RIP. The only way around that would be to run like another network cable between router 4 and 14 or something to kind of bypass these other routers over here, and it'll get a shorter distance that way. And that way it will put itself into that route. Just to demonstrate it here, let's do a ping 192.168.17.1. And it timed out. Now, let's do a ping of 192.168. Let's do, it goes all the way down to 15, so let's do 15.1. And that succeeded. So it went through. And of course the first ping failed there, which is common for any router, as it's just testing or pinging something for the first time due to ARP. This stuff isn't built into the ARP table yet, so it takes time to build itself into the ARP table before it really knows where it needs to go. So that's why that first ping always fails. Believe it or not, I actually had an instructor that did not know that he was using GNS3, and he actually thought that it was a bug in GNS3. So we tried to correct him on that. But so that's why. So just for FYI, future reference, if you didn't know that. So that cleared all the way through. Now let's go into router 12, since this has all the routes in it. I'll do a ping 192.168.17.2, which is the furthest away. That was router 18. That went through like butter. Now we'll ping router 0, which is 0.1. And that went through. So it'd be pretty well to assume that all these other ones are going to be good too. I can do 2.1. Oh. So those are going to be all good. Now, the problem with this, another one, it just keeps mounting up, doesn't it? Now, let's say, for instance, you do have a route in here. Let's say router 10. This has all the routes from router 11 over. So 11.0, 12, 13, 14, 15, 16, 17. That gets all those routes back to up here. Well, let's shut down one of the links and see what happens with that. So shut down. So what should happen is all of these routes that are over here that were being shared by this router to all of the other routers, it will have basically an update saying, hey, this route is unreachable now. All these routes are unreachable, so I can't use these routes anymore, so I'm going to dump them out of my routing table. So what it'll do is it'll actually hold it just in case there's just a little blip or something in the network. That way it doesn't have to completely delete everything out of the network and then just re-adding it, especially if you have like a flapping port or something where it, up, down, up, down, up, down, up, down. That way I'll just keep it in there, so it'll have that timer on it before it completely expires and deletes everything out. So now we've let this sit for a little bit. So let's we'll go to router 0. Let's do a show IP route, and as you see up here, 192.168.15.0 was the last network that it was able to see. Now what we got? Still 15.0. This is taking a long time to update. So in the meantime, this router thinks that 192.168.15.0/30 is reachable. It's in its routing table. It says it's there. So it thinks everything is, happy and honky-dory. But if you go to try to ping that, you're getting, now this is a different one for you. It's a U, which means it is unreachable. So even though it says that route is there, it's saying it's unreachable. Let's do a show IP route again. Still says it's there. This is the downside to RIP. It is very slow to send its updates out to everything saying, hey, these routes are down. So in the meantime, you have all this traffic trying to send out tons of, whatever you're trying to get to. If you're trying to get to a server on that end or web services, whatever. So it's trying to get to those, and all of these packets are trying to pass through, and it is not getting to anything. What we can do here is I'll switch to simulation on this, and we will fire a ping from router 0 to router 14. And we can actually watch this. You can see the little envelope up here. We will follow that and see where it goes. So I can speed this up a little bit. There we go. Router 5, 6, 7, 8. And then it blows up, which is where that dead link was at. So it can't go any further. So now it's sending the packet back saying unreachable. It goes all the way back. And this is your unreachable packet that you were seeing when you were doing the ping. Those are other updates that we're sending out for RIP. Is this actually this is CDP neighbors here. You can see it on my chart over here. So it's sending out a CDP, just seeing what neighbors are kind of connected to it. That doesn't really apply to any of this stuff. But it's cool to know nonetheless. Alright, so now we'll go back over to real time. Let's take a look, see if this is updated yet. Still, well, here we go. Possibly down. So now it knows that something's going on with it, but yet it still hasn't deleted out the routing table. So now it's going to give it that little timer, give it time to come back up, and then from there, then it will delete it out of the routing table. Possibly down. And you see it's doing it for each of them. As I said, this was at router 9, so this was 10 through 15 that it can no longer get to, possibly down, possibly down, possibly down, all the way through router to the 15.0 network. Still hasn't cleared out. Finally, it will, basically what happened, it'll time out and it'll eventually just clear it out of the route until this link happens to come back up. Then it'll send out the updates again, say, hey, these are my networks that I know of, and it'll just kind of spew out its whole routing table to all the ports that it can, which would be going out this way as well as this way from router 10. Because there is no a passive interface set on there, so it'll just send out all available ports. And if you don't understand what a passive interface is basically it allows you to put a command on a specific port. Say we have a computer coming off of here, or another switch that doesn't have any other routers in it, so it has no business doing anything with the RIP updates or anything. So to help eliminate some of your internet traffic, your network traffic, you can do a passive interface and give that interface number, put that into your RIP commands, and that way when it sends out its routing updates, it will not send it out this way. So that helps network traffic a little bit, and that is definitely needed with RIP because this is a very network intense routing protocol, because it doesn't just send little updates saying, okay, this little network here is down, this one's back up. It just basically takes that whole routing table and just, here you go. Here's everything I know about. Take it or leave it. So it's not very what would be the word I'm thinking of? Proficient, I guess. And still possibly down. So yeah, I think I made my point across with that. It's very slow. It's good for a little small network. If you have like a few routers or something you need to talk together, it'd be okay. Even then, I still prefer EIGRP. Just because it's fairly easy as well, and it's a lot quicker, less network resources required, as far as bandwidth as well as processes on the routers. So that's always good, especially if you're running some. I mean, these ones I'm simulating here, 1841s. They're those things are actually ancient now. You're up to past 1941s now. But those things, I mean, you start putting a lot of processes through, it's going to kill those routers, and then you're going to have a lot of network slowdowns because the routers can't keep up. What we'll do is let's go in here and do a no shut. We'll bring this back up. And now it's back up. It should spit out its routing table again, possibly down. So this is going to converge some more, and then eventually it'll come back up and everything will be all good. Obviously this is going to take a while for it to do it, but in good time it would come up. So I hope that is gave you a little bit of insight into the RIP routing protocol. As before I said, this was a version 2 we were playing with because we do VLSM. If you want to play around with the version 1, you can do that as well. But you'd have to make sure you have everything split into its own classful network. So instead of doing /30s between all these, I would have to do a /24 on all of them. As always, thank you for watching, and I saw I had a few new subscribers, so thank you guys for subscribing. And if you have any questions, comments, concerns, or ideas for other videos that you would like me to do, feel free to shoot them my way. And also, just an FYI, I was seeing that there was a 12-12 concert on for the Hurricane Sandy victims. It was actually a really cool concert. It had tons of huge acts there. Rick Springsteen, Roger Waters, Eddie Vedder, The Who, Bon Jovi, a bunch of other big acts that were there, all trying to raise money for Hurricane Sandy. So I don't know how long the website is up, but donate up, help the Hurricane Sandy victims. Help them rebuild their homes. There's still tons of people without electric and no heat. Still need clothes. So if you go to 121212concert.org, and it's 121212concert.org, so actually the number is not spelled out, and you can donate through there. I don't know how long their phone number is open, but you can call them at 1-855-465-4357, and you can donate to them that way. And actually, a lot of the celebrities were working the phones, Whoopi Goldberg and Jesse Jackson, Chelsea Clinton, uh, a few of the other people were in there. I think one of the guys from Pink Floyd was in there. I think it was Van. I can never get the guy's name. Robert Van Zan, I think. Um, yeah, call up, donate, do what you can to help the people in New York and New Jersey. And as always, thank you all for watching. I hope you all have a good Christmas.